Hi everyone. Today I'm going to pick up more or less where I left off in terms of discussing a few lines of Java code, what they do, and introducing you to objects and how to construct objects and how to use variables to reference objects and how to call methods on objects. So you recall that if you want to use a variable, you need to declare it. So let's declare a variable called s1 that's a string. Once you've declared a variable, then you can assign things to it. For instance, we can set s1 to point to a brand new string object of our own creation. By the way, this double slash is one way that you can do comments at the end of a line in Java. It's also possible to combine both of these two features into one step. So you can declare a new variable and assign it something at the same time. So that's a nice little bit of syntactic sugar in Java. So maybe you recall from last lecture that what these lines do is the first line declares a box, which is a variable named s1 that can store references to strings. And the second line constructs a brand new string object and the equal sign, s1 equals new string, creates a reference that's stored in the box s1 and that points to that new string object you've created. And this final line here does the same thing with another variable called s2 and also creates another new string object which is different from the first string object. Let's look at some other things we can do. One thing you can do is you can write s1 equals, and then you can actually write a string between quotes. And one of the things that's interesting about this line is that this also has a constructor in it. When you write in a Java program, open quote, yow, close quote, that actually creates a string object right there on the spot when you execute that line of code. And you get a string object with these characters in it. By the way, what is a string? It's a sequence of characters, like any characters you could type at the keyboard. And what is an empty string? Well, an empty string is a string of characters that has 0 characters in it. So you can think of this maybe as being the same thing you'd get if you typed open quote, close quote with nothing in between. So now we've created this new object, and once it's created, the equal sign takes a reference to that object and stores it in the s1 box, which overwrites the old value in the s1 box. So now s1 points to the new object and the old one is forgotten. Another thing I can do is I can assign from one variable to another. s2 equals s1. That line of code says take whatever is stored in the s1 box, meaning this reference here, and make a copy of it and store that in the s2 box. So effectively, the old reference in s2 gets overwritten and replaced by a new reference. And you'll notice that Java did not create a new object here. s1 and s2 are now actually pointing to the same object. when you're writing Java programs, it's going to be really important for you to distinguish when two variables are pointing at the same object from the case where they're pointing at two different objects that happen to have the same data inside them. So try to keep track of that in your head when they point at the same thing and when they point at two different objects. What if, in this particular case, we wanted S2 to be a copy of S1? Like we wanted to make a copy of this object instead of having both pointers point to the same object. How could we do that? Well, Java has a constructor that lets us do that. You write S2 equals new string, and then in parentheses, you write S1. So this looks kind of like this, except we've thrown a constructor in. And so that last line of code does something fundamentally different. What this line of code does, well, this one line of code does 5 different things. So follow along with me here. First thing it does is it looks in the box S1 and it sees what S1 is pointing at. The second thing it does is it follows that pointer and it finds the object. The third thing it does is new string constructs a new object which is a copy of the original string. Actually, I suppose I should have divided that into 2 things. The third thing it does is really it reads these characters that are inside that string object. And then the fourth thing it does is it creates a new string object that has the same characters inside it. And finally, the fifth and final thing it does is this equal sign here, the assignment statement, which takes a reference to the brand new object we've just created and writes it into the S2 box, which also has the effect of overwriting and erasing what used to be in the S2 box. So, now that we've done that, S1 and S2 now refer to 2 different, albeit identical objects. Are there any questions about that? Yes?
When S2 is pointing to the same object as S1, if you change what S1 is pointing to, does that also change S2?
No. So the question was, back when S1 and S2 were pointing to the same object, if I had changed what S1 is pointing to, would that have changed S2? The only way to change what S1 is pointing to is to write a new arrow into this box that points to some other string. But that does not change what's written into the S2 box. And it just so happens that in Java, you can't change a string object directly. There are some types of objects where you could actually make a change inside this box, but strings are not one of them. Other questions? Yes? Can you speak a little louder, please? Mm-hmm. Uh-huh. That's right. So once you've done that, it is no longer true that S2 equals S1. And really, I don't want you... In Java, equal signs do not mean equals. They're not mathematical equality. And this is one of the confusing things about Java, and it's kind of a design flaw, is that the equal sign means assignment. It means take a copy of something that's stored in one box and store that copy in another box. And it really has nothing to do with mathematical equality. And that confuses people at first, but try just not to think of an equal sign as having anything to do with math. Thank you. Yes? No, it is not possible to fix S2 so that it will always point to the same thing as S1. As soon as you change one of them, the other one's still going to stay the same, unless you explicitly change them yourself. Other questions? Yes, over here. No, it is not possible to have anything that points directly to a variable in Java. Yes? If you write S2 equals quote S1? Oh. If I said S2 equals Yao, then yes, in this particular case, it would have had exactly the same effect as this line did of creating two different objects. And S1 points at one of them and S2 points at the other. Yeah, question. Java does not allow you to access random memory locations. That's right. And the reason is it's trying to protect you from shooting yourself in the foot. There are languages like C that do allow you to access any memory location you want. And that can be very powerful sometimes, but it can also make some programs really hard to debug. So I think I'll move on from here. All right, so in these little examples here, we've actually seen three different string constructors. The first one, we just type new string, open paren, close paren. That constructs an empty string. And what is an empty string? Well, it's a string, but it contains no characters. It's like I said, a string is more or less anything you can type at the keyboard. An empty string is if you just sat there looking at your keyboard and didn't actually type anything. The second example was you can just stick something in quotes, like whatever word you want to type. And that just automatically constructs a string with the characters that you specified in your program. And the third example was new string again, except this time the invocation, new string, takes a parameter. S1. Parameter means the same thing as argument. I'm not sure which word you guys prefer to use in 61A and other such, but I always use parameter instead of argument. And what this constructor does is it makes a copy of the object that S1 references. By the way, not all objects behave this way, just strings do. So those are the three constructors so far, and I want to make a more general point, which applies to all classes of objects and not just string, which is that constructors always have the same name as their class. Except for that very magical exception when you put stuff in quotes. And Java magically makes a string for you. That's pretty much the only exception we're going to need to worry about this semester. I think I saw a couple of questions over here. Yes? Number one, you cannot put stuff inside the parentheses for that particular constructor. But there are other string constructors where if you do put something in parentheses, you will call one of those other constructors instead. If you want to do what? Oh. number 2 is pretty much the best way. There is another one that, for instance, will convert an array of characters into a string. But that, you can learn about that later in the semester. Question over here. Okay. Well, S1 by itself is a variable of type string. String S1 is a constructor call. Though I could sort of say that new string S1 is a constructor call too, because you're really only allowed to call constructors by using the new keyword in Java, except for this exception. But this constructor call also returns a value that you can use, and the value that it returns is a string object, or a reference to a string object. I hope that answers your question. Okay. In the back there, near the back. Yes? Mm-hmm. Well, to be perfectly accurate, I'd say that the reason the constructor has to be of the same name as the class is because that's just an arbitrary rule that the Java designers decided to use. Does that answer your question? Java will not allow you to define a constructor that has a different name from the class that it's defined in. So you just can't do that. Yes? Text. Something instead of S1? Are you sure you mean parentheses? These are parentheses. In quotes. Oh, yes, in fact, that's true. You can do that. I can say this. It's not very useful to do this, but here's what it does. First, it constructs an object, a string object with the letter A in it. Then it constructs a copy of that string object with the letter A in it. And then you can do whatever you want with the copy, except the original, you've already lost it. So you've just basically wasted time making a copy and then throwing one away. But it's useful to know what these things do. So, question over here. Single quotes means something different. Single quotes are used for individual characters. You need double quotes for strings. All right, I think I should move on from here. By the way, these are not the only string constructors. There's a whole bunch of different string constructors that differ based on what parameters you give them. And you can check out the online Java API to see all those different string constructors. And you'll learn how to check out the online Java API in your first lab next week. All right, what we're going to do next is we're going to look at some methods that are not constructors. And this sort of standard way you do a method call in Java that is not a constructor is, well, first of all, you have to have an object that you want to call a method on. So here's a string S1. I'm going to call a method that operates on that string, actually the string that S1 references. So what I'm going to do is I'm going to take this string S1. That means what S1 here is pointing to. And maybe I want to convert it to all uppercase letters. So there's a method that does that. It's called toUpperCase with a capital U. And so what that does is it follows S1, this pointer, finds the object that S1 points to, sees that, hey, this is a string, and I want to call this toUpperCase method that operates on strings. What toUpperCase does is it calls a constructor itself that creates a new string, and then toUpperCase changes that, well, makes sure that that string has all uppercase letters and returns that string. So the toUpperCase method returns a string like this. And then the assignment statement, as usual, will erase the old value of S2, and now S2 points to this string instead. Question? Uh-huh. That's not a question with a simple answer. What I'm going to ask you to do is go through the next month with me, and then I think the answer will be clear. I'm really not messing with you here. I really think that object orientation is a fundamentally different way of thinking, and it will take a while until we see all the features of object orientation before I can answer that question. In particular, you'll have to learn about polymorphism before I can really give a good answer to that question. And that's going to take us about a month. Let me finish this section before I take more questions. Let's try a few more methods. Another method is called concat, which is short for concatenate, and it's used to concatenate two strings together. So here I'm saying I want to make a new I want to create a new string. Well, concat calls a constructor that creates a new string and returns that new string, and that new string is the concatenation of S2 with another string that's passed in as a parameter. And so now you get the original S2 string with two additional exclamation marks concatenated on, and that gets assigned to S3. Or it's perfectly okay to actually write a string in line like this, and then can call a method directly on this string that you've just constructed. So I can take a string and concatenate S2 to the end of that. And not only that, but I can daisy chain these things. So once this concatenation gets computed, it returns a string. I can call another method on that string, like concat again. And now those two together construct this string and make S4 point to that. Now, Java provides a special shorthand for concat. If you add two strings together, Java automatically implicitly converts that to a call to concat. So I could have written this line S3 equals S2 plus this other string. And this last line here, I could have implicitly written this as S4 equals asterisk plus S2 plus asterisk. Okay, questions about this now? Yes, here. I don't know my scheme very well, but I think it probably is. Question here.
So do you have to create a new string, or can you just assign a string to, like, do something like S2, assign S2?
Well, so one of the things about Java is that strings are immutable, or string objects are immutable. You cannot change a string object. So anytime you want to have a variation on a string, you have to construct a whole new string to get that. So does that answer your question? Okay. How about you, ma'am? Well, I'm assuming that these lines of code are executed after these lines of code. So I did not declare S2 here because I already declared it up there. But this is the first time I've used S3 and S4, so I need to declare each variable once and only once. Okay. Question here? I'm not calling a constructor in these lines at all. So, right, there's no constructor there, so there's no new. This is a declaration, it's not a constructor. And concat is a method that is not a constructor, although it does call an instructor internally. It's not a constructor itself. Other questions? You, sir.
Going off that, what you just said about string concatenation.
Uh-huh.
So would it be like that tag or like you already had that now?
Uh-huh.
S1
It wouldn't change it, it would just create another. And that's what all these lines are doing too, is they're creating new strings, but all the old string objects are still there. Well, actually, Java has something called garbage collection, which erases objects that can no longer be accessed from any variable at all. And we'll cover that at the very end of the semester, how that's done. You in the back, sir.
What would happen if you put something
You know, I don't have the Java API handy. It has literally thousands and thousands of methods, and I can't memorize them all. But I don't think, off the top of my head, that there is a method to uppercase that takes a parameter. I could be wrong, though. I could easily be wrong. Yeah, Java requires that every method call and every constructor call always has parentheses after it, even if there are no parameters. And that's to differentiate methods from variables. Question in here.
Just as an update to uppercase, it actually does have one version that takes
Okay. Well, there we go. So there is one, but Lord knows what it does. It's one of these. You guys will learn next Monday how to look up the Java API and see these thousands and thousands of methods for yourself. You, sir. No, because then you'd have a character, and I don't think, well, characters are not objects in Java. They do not have any methods that you can call on them. Question here. Well, that's a very good question. So what order do these concat methods execute in? Is it left to right or is it right to left? The real rule is that to call any method, you have to have an object to call it on first. So what object is this concat being called on? Well, that object has to be created. Basically, this stuff collectively creates an object, and only once that object exists and has been computed can we call this concat at all. Any more questions? Yes?
Does a string have to be written on one line? Or could you put a break?
I think the way to put a break in a string, I know C supports this, I'm not sure about Java, probably it does. What you can do is you can put a string on a line, close off the string, open up the string again on the next line, and close it off. And if there's nothing between here and here except white space, C at least will concatenate them into one string, and I'm not sure if Java will or not. I hope it does. So I think I'll move on from here. All right, so I want to point out again that the original object, all right, when I executed this line, S2 equals S1.2 uppercase, the original object that S1 was pointing at, meaning this object right here, did not change. That object is still there. It's still the same object it always was. And I know I've said this already once, but it's important enough that I want to make sure it's written down. So the object did not change. What happened is that the variable S2 changed. Now, unlike in C, in Java, string objects are immutable. And immutable means their contents never change, because Java does not give you a way to change their contents. This is not true of most objects in Java. In Java, most objects, you can change their contents, but strings are an exception. Strings are immutable. Question here. Yeah, so if I type s2 equals s2 dot uppercase, then it will indeed make a new string object, and the old one basically gets thrown away. And if I execute that 1,000,000 times, it will make 1,000,000 new string objects. All right. I want to talk a little bit about I/O so that we have some ways of interacting with the user so that you can read stuff from the keyboard and write stuff out to the screen, especially the latter. Java has built-in classes and methods to help you do this, and they are in the built-in system class. And these objects are automatically created for you at the very start of your program, and you can just use them. So one of these objects is called system.out, and it is an object of the class printStream. And it outputs stuff to the screen. There's another one called system.in. It's an object of the class inputStream. Its job is to read stuff from the keyboard. System.out is easy to use. It has a printLine method that can be applied to the system.out object that lets you just print any old string you like to the screen. System.in is a little bit more complicated. And by the way, I just want to say, when I say system.in is an input stream object, that's really shorthand for saying that system.in is a variable that references an input stream object. And I'm going to use this shorthand all through the semester. Now, question?
Yeah, how do you know how to stop using like
How do I know when to what?
Like you put in like the call system in, type in, right? How do you know how to exit?
Well, one way is to just try to read a whole line at once, which is what I'll show you how to do right now. And then when you hit the Enter key, it will stop reading the line, and then it will return it to you. So their method that does that is called readLine. And the readLine method is defined. Unfortunately, it's not defined on input stream objects. We would like to use readLine because we want to read a line from the keyboard, but it's actually defined on a different kind of object called a buffered reader object. Okay. So if I want to read a line, I need to get one of these buffered reader objects that is somehow connected to the input. I'm going to do that. Well, I got to construct one. How do we construct a buffered reader? Well, one way is with an input stream reader. Okay, it's not a very enlightening answer. How do we construct an input stream reader? Well, to construct an input stream reader, we need an input stream to construct it on. How do we construct an input stream? Well, lo and behold, system.in is one. So we have one of those. How did I figure all of this out? Well, as with most things in Java, you figure out what you want to do, and then you look in the Java Online API to find out what methods exist to help you do it. Specifically, you look in the java.io library. Which has lots of stuff that does input and output. Now, you got to wonder, why all of this fuss? Why do we need to create this long series of objects in order just to read some stuff from the keyboard? And here's the reason why. The input stream objects, their job is to read raw data. From the keyboard. And this is just a totally unformatted bit stream of raw data. That's its job. That's all it does. And then it passes that on to a different kind of object. And what this object, input stream readers, know how to do is take a stream of raw data and compose it into characters. And Java uses Unicode characters, so these are typically 2 bytes long. Although that can be changed. And finally, what does a buffered reader do? A buffered reader's job is to take a bunch of raw characters and compose them into entire lines of text. Now, why is this stuff divided into 3 separate tasks? The answer to that is what's called modularity. The idea is that you can take any one of these 3 tasks and completely re-implement it from scratch without affecting or changing the other 2 tasks at all. So if you think you have a much faster or better algorithm for composing characters into lines, you can replace this and not have to write a single line of code to do this or to do this. So now that we've got all of this stuff, let's put it together into a Java program. This will be your first complete Java program, and what its job is to do is to read one line of text from the keyboard and then print it out on the screen. And here's what it looks like. A lot of this will be cryptic right now. So just get used to the idea that it's going to take about 2 or 3 weeks to understand what all of the words in this program mean. Okay. SimpleIO is the name of my program, by the way. So I'm creating a class specifically to be a program whose name is SimpleIO. And I'm going to write a method in that class. And that method is called main, just like in C, for those of you who've programmed C. Okay, so far, these first 3 lines, just accept that you'll understand them later in the semester and don't worry too much about them right now. Right now, what you need to know is that when you want to write a Java program, you probably want to roughly copy these lines. You know, change SimpleIO to the name of your program, and you don't always need this throws exception, but this is basically how you start a Java program. And now we can actually get down and do stuff. And what we want to do, first of all, we want to construct a buffered reader so that we can read something from the keyboard. So let's do that. I'm going to declare a variable of type buffered reader. Call it keyboard. And I'm going to assign it a new buffered reader object that I'm going to construct right now. And the buffered reader constructor takes one parameter, which is an input stream reader. How am I going to get an input stream reader? Well, why don't I create one right now? And I'll create, now the input stream reader also takes a constructor, which is an input stream. And the input stream I want is the one that comes from the keyboard. System.in. So there, I've created the buffered reader that I need to read stuff from the keyboard. And now, I'm going to use system.out to print one line of text. Where am I going to get that line of text from? I'm going to get it from the readLine method that I was talking about up here. Which I will call on the object keyboard. And a couple of closing braces, and that's the whole program. Am I missing something? I'm probably missing a paren here. Am I missing anything else? I think that's everything. You call SimpleIO from the Unix command line. So it just calls main automatically when you specify what class you want to run. Question in the back? Well, let me write down a few things about a few of the lines, and then I'll try to do that. So first of all, let's look at the first line, import java.star. It's a fact that if you want to use any built-in Java library, with one exception, java.lang, which is included automatically, then you need to import those libraries. Now here we are importing java.io because it includes the input stream reader and the buffered reader classes. So that's what the first line's all about. The second line is the name of the program. The third line is there because any Java program always begins at a method called main. Which is usually defined pretty much as it's defined right there. That's just the standard way to define a main method. So that's what the third line is all about. The fourth line is about creating a buffered reader object that we can read stuff from. So what this line of code does is it takes system.in and it passes it to the input stream reader constructor, and that creates an input stream reader object. We don't even store that in a variable. Instead, we just take that input stream reader object and pass it directly to a constructor that constructs a buffered reader object, which internally uses the input stream reader object. Once we have that, the variable keyboard is used to reference that buffered reader object. And now that we have a buffered reader, we can call the readLine constructor on that buffered reader, which reads a line of text from the keyboard. And then finally, that line of text gets, or that string gets passed to the println method, which prints it out on the screen. Okay. Before we part, let me just put one thing up on the Elmo to show you. One small change that will come up in your first homework, which is, suppose instead of reading the line from the keyboard, you want to read it from a web page. Well, you can use virtually this same infrastructure here to read something from a web page. The difference is the way you create the input stream. Instead of using system.in as your input stream, wow, this is blurry. Is this the Elmo that's blurry, or is this just the way it is? Huh. What the hell? There we go. So the main thing that's different here that you should be looking at is the first line, this line that says URL, U, equals new URL. And then if you want to look up the White House website, this is how you do it. You just pass in the URL that you want as a parameter to the URL constructor. And that gives you a URL. And then you can get an input stream out of that URL by calling OpenStream method on that URL. And then from there on in, everything else is done just the same as in the example program I just gave you. And so you'll want to use that more or less directly in your first homework. Questions? Yeah? Oh, that's too bad. Okay. I was wrong about concatenating strings. I don't know how you're supposed to... If you want a really, really long string in Java, I don't know how to put it in multiple lines. Question here. What's what? Oh, this is going to be in the lecture notes, so that I put online after the class.